Google, by itself, uses more electricity than over 100 countries combined. To keep that many machines from melting, it pumps billions of gallons of water every year. There's no literal underground ocean, but the real infrastructure required to run something as simple as a Google search is stranger and bigger than almost anyone realizes. Start with the electricity. In 2024, Google's data centers alone consumed 30.8 million megawatt-hours of power, roughly double what they used just 4 years earlier. To put that in perspective, that's more electricity than entire countries like Ghana, Tunisia, or the Dominican Republic use in an entire year, combined with dozens of others. And Google isn't even the biggest single consumer in tech. Microsoft is right there with it, using a comparable amount. Together, these two companies alone now use more power than more than 100 nations on Earth, and their electricity use has been growing by double-digit percentages year after year, driven almost entirely by one thing: the race to build and run AI. All of that electricity becomes heat. And heat is the actual engineering nightmare nobody outside the industry thinks about. A data center is essentially tens of thousands of computer processors, all running at full tilt, packed into warehouse-sized buildings. Left alone, that much concentrated processing power would overheat and start failing within minutes. So the entire physical design of a modern data center revolves around one unglamorous problem. How do you move an enormous amount of heat out of a building, continuously, 24 hours a day, without it ever stopping, and without wasting so much energy on cooling that it defeats the purpose? Engineers actually measure this trade-off with something called power usage effectiveness, or PUE, essentially a ratio of how much total electricity a data center uses compared to how much of that electricity goes directly to actual computing versus how much gets eaten up by cooling and overhead. A theoretically perfect data center would have a PUE of 1.0, meaning zero energy wasted on anything except the computers themselves. As of 2025, Google reports an industry-leading average PUE of 1.09, remarkably close to that theoretical limit, and roughly 84% better than the industry average. That efficiency didn't happen by accident. It's the direct result of obsessively engineering the cooling systems that keep these buildings from cooking themselves alive. The most common tool for that job is water, and it's thirstier than almost anyone realizes. Evaporative cooling towers pull heat out of a building by evaporating water, the same basic principle as sweating cooling down your skin. It's remarkably energy efficient, which is exactly why it's so widely used. It's also remarkably thirsty. Google has reported that a single average data center can use around 450,000 gallons of water a day. Some of its larger sites use dramatically more. One facility in South Carolina alone used over 662 million gallons in a single year. Its data center in Council Bluffs, Iowa, one of the company's largest, has been reported to draw an average of nearly 4 million gallons of water per day. Across Google's entire global operation, water consumption for cooling has been reported at close to 8 billion gallons annually as of 2024, and rising fast as new AI-focused data centers come online, since AI workloads run processors far harder and far hotter than ordinary web traffic ever did. That water has to come from somewhere, and that's where this story stops being abstract and starts becoming a real fight over local resources. In several U.S. towns, local water utilities have had to negotiate directly with Google over exactly how many million gallons a day a new data center will be allowed to draw, sometimes from the very same reservoirs that supply drinking water to nearby residents. In one Virginia county, officials agreed to supply a new Google data center with up to 2 million gallons a day at first, scaling to as much as 8 million gallons daily as the facility expands, pulled straight from a public reservoir that also serves local communities. In Oregon, records revealed after a lawsuit showed Google had quintupled its water use in one town over roughly a decade, eventually consuming nearly 40% of that entire town's total annual water supply. That's not a hidden underground ocean. It's a very real, very public negotiation over a genuinely scarce resource, happening quietly in small-town water board meetings around the world, largely outside public attention until residents start asking why their taps are running dry. To its credit, Google has publicly committed to replenishing more water than its data centers consume by 2030, and reports that more than a quarter of its data center campuses already use reclaimed or non-potable water, wastewater that would otherwise just be discharged into a river instead of fresh drinking water. Whether that fully offsets the local strain in every community it operates in is still an open, actively debated question. Not every company is solving this the same way, though. Some have tried something a lot stranger. In 2018, Microsoft actually sank a fully sealed, self-contained data center onto the seafloor off the coast of Scotland as part of an experiment called Project Natick. The idea: cold ocean water surrounding the sealed container could passively absorb heat without using a single drop of fresh water or one mechanical cooling tower. When they pulled it back up 2 years later, the servers had actually failed at a significantly lower rate than equivalent data centers on land, partly because the sealed, nitrogen-filled environment protected the hardware from temperature swings, humidity, and human interference entirely. Google itself has taken a related but less exotic approach at a facility in Hamina, Finland, a converted paper mill that pulls in cold seawater directly from the Gulf of Finland to cool its servers, then returns the water to the sea afterward, avoiding fresh water entirely. Other companies have gone the opposite direction on land. Toronto runs the largest lake-powered cooling system in the world, drawing cold water from deep in Lake Ontario to cool office towers and data infrastructure across the entire downtown core, at a capacity of over 700 million liters a day. So the water problem is real, and companies are experimenting with genuinely unusual solutions to solve it. But water isn't even the biggest number in this story. Electricity is, and the reason it's exploding right now isn't search. It's AI. Every single AI response you get from a chatbot costs real, measurable electricity and water. According to Google's own published research, a typical text prompt sent to its Gemini model uses about 0.24 watt-hours of electricity and roughly a quarter of a milliliter of water. OpenAI has reported a similar figure for ChatGPT, around 0.34 watt-hours per prompt, describing it as roughly the energy a high-efficiency light bulb uses in a couple of minutes. Individually, those numbers sound almost too small to matter. The problem is scale. Nobody sends just one prompt. These companies handle billions of queries every single day. Multiply a small number by billions, repeated every day, all year, and you get genuinely enormous totals. Independent researchers analyzing GPT-4o's real-world usage estimated its 2025 electricity demand at somewhere between roughly 390,000 and 460,000 megawatt-hours, comparable to the total annual electricity use of 35,000 American households, or around 325 entire universities. And that's for text responses alone. Longer, more complex reasoning-style AI responses, the kind that think through a problem step by step before answering, have been measured using anywhere from 10 to 70 times more energy per query than a simple response. The International Energy Agency projects that global data center electricity demand could exceed 945 terawatt-hours by 2030, slightly more than Japan's entire current electricity consumption, and AI-optimized data centers specifically are identified as the single largest driver of that growth, with demand from AI workloads expected to more than quadruple within the same 5-year window. None of this means there's a literal secret ocean buried under a Google campus. What's actually there is arguably more remarkable: an entire hidden layer of global infrastructure, power plants, cooling towers, undersea cables, seawater intake pipes, negotiated water rights with small towns, all quietly built just to keep a search bar responding in under a second, and now, increasingly, to keep an AI chatbot answering in real time. Every time you ask an AI a question, you're not just using software. You're pulling, in a very small but very real way, on an ocean's worth of water and a small country's worth of electricity, spread across a fleet of buildings most people will never see and most companies would rather you never think about. If that changes how you think about the next question you type into a chatbot, that's exactly the right reaction. Subscribe for more deep dives into the hidden infrastructure that quietly powers the internet. And tell me in the comments, did you know AI queries had a real water and electricity cost before this video?